Hi, everyone, and welcome to the week 4 of Introduction to Structured Programming. Today we're in a bit different setting. I hope that this is working fine for everyone. David is also here.
Hi. Yeah,
Maybe we
so
can get some
please,
feedback on the audio because this week is a bit unusual.
even more unusual than usual because you are still at USA, yeah, but I'm also not at home. I'm not at Graz. I'm in Greece actually at a conference. So we are both abroad and I hope it works. So I hope you can understand us. Yeah, works fine. That looks good.
It
Great.
works fine. Yeah, for this week
Great.
we're good with just fine. Next week we'll promise everything will go back to as usual.
Yeah,
But
because then I have the responsibility. Then it must be better.
do you want to say when I have the responsibility, it's not working good?
It works perfect. All good, all good.
Okay, yeah. All right. Yeah, I would say let's go into today's lecture since we have a couple of things on our plan for today. Actually, today we want to dive into the C programming language, what you also did with Julia and Michi already. But yeah, this week it's more about some basics, some fundamentals that we want to show you. All right.
So Alex, I think you should move a little bit to left so my inner monk cannot see it like that. So you are on the left corner, so please
Like that?
move yeah, a little bit more.
Is it okay now?
But it's fine, yeah. That's fine.
Okay,
That's
perfect.
acceptable.
Perfect. All right. Okay, cool. Yeah, some organizational things that we want to discuss with you. I think Michi and Julia already mentioned the most important parts about the assignment one, which will go out today. It will be published after the lecture today, so 6:30, I guess. Um, and there you will see the kickoff video on YouTube. We will post it anyhow later on the Discord server, then you can watch the video. This video is created by Lena. It's a great video which gives you some information how actually you can access the assignments, what you have to do, and stuff like that. The the repositories will be online by tomorrow latest, and then you have all, yeah, what you need for the assignment. Another point, start early, really start early. This is something that we always see in ESP. We also got some last minute emails for the homework too. And since we have a course with over 700 students, we have to have some, yeah, strict organization on these belongings. So please make sure you start early, that you can test everything and program everything. If you're experienced in programming, the first assignment might not be a big deal. Anyhow, start early. And if it's your first programming assignment so far, then really start early because it might take some time to get into it. Yeah.
Yeah, in general, most of the people would underestimate the effort they need, especially if
Yep.
you are not familiar with programming. So worst case scenario would be that you are finished too early, but it's not possible. So um, start early is the most important tip we can give you.
Yeah. And there is a huge difference between homeworks and assignments. Homeworks are 3 points per homework. Assignment one is 18 points. So when you see the weight of the or distribution of the points, it should be clear that it's much more work and it's yeah larger in total. Anyhow, we try to have a nice first assignment, which of course should have some complexity, but we gave you all the background that you should have to do this now. I think a very first important step for most of you will be to set up everything, to have the VS Code running, to compile actually, to write code. And so keep that in mind as well, that you have to set everything up for the first assignment especially.
And
Okay, short.
one question in the chat was if the assignment is for the lecture. No, the assignment and the homework and the coding sessions are all for the practicals. For the lecture, you just have one exam where you can register in the Theoclass online. So the lecture is really just one exam. Everything else is in the practicals.
Right. Okay. David, do you want to give a short recap what we did the last week?
Yeah, sure. So we get to know 4 types of computational thinking: abstraction, decomposition, algorithmic thinking, and pattern recognition. So maybe go to the next slide and we go through these types of computational thinking. So this one was maybe a short question in the chat. What is this, or what type of computational thinking was this? So we have some really complex computer in this case, and we make more simple abstraction. Exactly. So this is abstraction. So make very complex, detailed things into more or better. How do you say, better representation to think about it, and more easy understandable representation. I think that's a good word for that.
Yeah, right.
The
We
next thing,
also talked about Super Mario in the last week. So what we did here is to have a huge game or whatever and break it down into manageable parts. So to decompose things and to actually have a look at Super Mario and see what elements, what game elements we have in the game. We also talked about functions, and we will continue talking about functions today. We talked about things, syntactical things last week already, or last time. But this week will be mainly about how to do this in C, actually, because we try to give you already some idea of what a function is, how you can write it, what components a function consists of, and this week is more about how it can be done in the C programming language, actually.
yeah, then we talked or we showed a little bit about algorithms. First of all, maybe the most funny part, even just for me, but for me it was very fun. It's where I destroyed the phone book. I heard that the chat was not that happy about that, but I had fun. Where I showed you the linear search and binary search, so different kinds of how you can search in a phone book, for example. Then we showed you the friendship algorithm from Sheldon Cooper, where we also presented a short pseudocode of this. So a little bit of algorithm where, let's say a big topic or a big problem is divided into small things, and then we tried to write pseudocode. Okay.
Right. Okay.
So we also talked a little bit about arrays, and I think you have to one more after. There's something with the animation which does not work probably. Go to the next slide, Alex. Yeah, thank you. Okay, even one more. Yeah, so now I have to index and the values here. So we talked about the integer arrays or arrays in general, which is just continuous memory location. So a group of elements, and it can be any type of data. It can be integers or it can be characters, as we see down or below in this string is then a character array. and each string ends with this 0 byte, so this backslash 0. And you can see also that after that, any random values can also be stored in the memory locations afterwards. So if we do not have this null byte, this 0 byte here, uh, the program would read all the things that are after our string and do not cut it or make the end of the string. So it would just read until it finds some memory location where there are just zeros. And that's a very common error. So keep in mind at strings always have to end with a 0 byte or a null byte.
Right.
Yeah, and we talked a lot about different data types. I think Michi and Julia also showed you a bit about different data types, Boolean, characters, integers. So they all use a different amount of storage. So they have more possibilities to display higher or lower values. And the string, as I said, 1 byte per character is used plus the null byte. So you always have to consider that you need 1 byte more for the null byte in the end. So that was the short recap. Anything to add from your side, Alex?
Not really. I think that's it, actually. If there are questions you have from the last weeks, because you, I don't know, rewatch the lecture, whatever, please just type in the chat and we are happy to answer them, of course. Now I want to go to something new, but honestly, it's not new for most of you because, yeah, most of you already know about that. And so we use them actually already. We want to talk about operators in the C programming language. And there I want to start with something that we used already a couple of times, but now you have the formal idea of what it is actually. The assignment operator. And this is this very simple thing that you will do billions of times in your career, probably. We have a variable and we assign a variable a certain value. For example, we have an integer x and assign the integer x the value 6. We also have the integer y, assign the value 5. And then what we also could do, of course, is to say we assign the result of an addition. So we say x plus y and assign this value to z. And that's actually what we're doing here. We assign from the right to left. So 6 should be in the variable 5, or the variable x should contain the value 6, actually. So that's the idea of the assignment operator. I think this shouldn't be that confusing. I want to show you some arithmetic operators as well. We can use some basic arithmetic operations like addition, subtraction, multiplication, division. So by saying x plus y, we have an arithmetic operator. And for the plus, we always need two operands. So we have something plus something, and we assign this to a certain value now here, like to a variable. I think this should be also clear. Question to the chat, would this work? We have two integer variables, 6 and 5, and now we want to have the result of the division x divided by epsilon.
Does it work is an interesting question. So
Yeah, I asked this on purpose like that.
okay, yeah, and the response in the chat are that yeah, not accurately, kind of, yeah. So they're not quite
That's the
sure.
cool that's the cool thing actually. If you have online GDB open next to you, just try it actually, because it will work. So the compiler won't blame you and say, "Oh my God, you're dividing two integer numbers, so two ganzzahlige Nummern." So it's working, but not how we want to have it working, because we say we have an integer, and as I said, integer is a Ganzzahl, which is no floating point number. So if we divide 6 and 5, what will happen is that we get 1, because we get an integer again. So if we divide an integer by an integer, we will get an integer back. This might be helpful, but usually in that case, probably not. Any ideas how we could fix that actually to get a floating point representation of that? Any ideas?
My idea would be to make a plus symbol. Then it's correct.
Yeah, it's correct, but we don't have a division.
Okay.
Casting is an interesting idea. We haven't talked about that yet.
Yeah, we'll come to that. Yeah.
Mhm. There are many correct answers. The answer of syntax, for example, is correct. We assign it to a float. This is an important first thing. Instead of int, we have to write float or double here. But also one of both operands has to be a float, at least one of them. So if we have y, for example, which is a float as well, then it would work. You can play around with that a bit. This is pretty interesting to actually see what we could do, and when it's working, when it's not working. This helps you a bit to get the idea of what data types actually are, how they are represented. This actually makes it a bit fun even to play around and check out
So,
these
but
things.
basic rule of thumb is one of them has to be a float, right?
Right, 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 right. Yeah, so when we talked about arithmetic operators, we saw usually binary operators. Binary means we have two operands, like 6 plus 6. But there is another cool thing in many programming languages, actually, which are unary operators. The cool thing with these is you can increase or decrease um, in a very simple way. As you can see here, we have a variable x, which has the value 0. And if we say x plus plus, then we say, okay, actually, this is x equals x plus 1. So we increase it by 1. This is all that plus plus does. It says add 1. And we can do the same with the decrement. We can just say x minus minus, and then we will get minus 1 in that example. So actually, this is the idea. With plus plus, you can increase by 1. With minus minus, decrease by 1. Yeah.
And so I thought when I learned this is when do I need this? But this is, I think, one of the most used operators in general in C. So I really use it. I think I've used it the most. So this plus plus or minus minus, so these
Yeah.
unary operators are used very frequently, and you should get used to it because you will see them very often.
Yeah, you will see them very often, especially when it comes to for loops, for example. This is something where you like always have it
Yeah.
like that. All right. Yeah. It depends also. You can put the unary operator on two different spots. You can put it at the end. So here, then it's postfix, so at the end, or prefix, then it's before the variable. This makes a difference, and you can use here minus minus as well, and here plus plus as well. the difference between postfix and prefix is when it gets incremented or decremented. This causes sometimes a bit of confusion, actually, because when you have minus minus x, it's decremented. It's minus minus x, it's decremented first. And when you say x minus minus, then it's decremented after that. I think this will get clearer if we have some examples with that, and if you also use it in some of the assignments, because then you actually see where value does change and why it does change.
Yeah, in this case, the theory is often not that understandable, so we have to try it.
Yeah. Okay. What you can do is you can combine arithmetic and assignment operators, which is actually also quite useful. With x plus plus, you can increase by 1. That makes sense sometimes, but actually sometimes you want to increase by 3 or 4, whatever. What you could do here is to say x plus equals 6, and this is actually just the abbreviation for x equals x plus 6. So it's just a short version of that. It's working with all the arithmetic operators, so you can use this with plus, with minus, with the division, so whatever. Another type of operators are relational operators. We talked about arithmetic operators, so to add things, subtract things. What we want to do now is to have relationships between operands. And this is something that you would also use quite often. I will guide you through this example, which is basically quite easy. We have an integer variable a, and what we assign is the right value to the left. So what comes first is this part, and after this part, we assign the result. So don't read it as a equals 5 and then the next operator happens. It's first that this 5 less equals 4 is evaluated, and then the result is put into the variable a. So what happens here? We check if 5 less equals 4, which is false. And so this variable stores that it's false. What it really stores is something different, because in C, or at least in the standard C that we used so far, we don't store false and true. Does anyone have any idea what is actually stored in the variable a after this line of code?
Yeah, we can see now who was in the practicals.
Right.
They showed it there.
0. Right.
Perfect.
Perfect. Yeah. And in all the other versions here, we say, okay, 5 equals 5, which is true, which is 1. And question about C, does this work actually? So when I say A not equals B, what is actually evaluated here? Does anyone has any idea? What are we doing here? Perfect. NG3D already gave the right answer. What we actually do is we compare 0 and 1 and say it's not equal, and it's not equal actually, and so it's true. Perfect. Very good. I hope this isn't too complicated so far, but this is what we can do with these relational operators. We can combine these things together, and this often happens with logical operators. So, Sasha, that's a good question. Equals equals, like this 5 equals 5 is like a comparison between 5 and 5. And this exclamation mark equals means you say not equals. So it's the opposite, actually. I hope this makes sense. Yeah, here, small example. What we do is we check if a character is lowercase. So if the B, for example, is lowercase, what we do, we check first, is the value, is B larger than A, and this is actually the end, smaller than Z. And the cool thing, it has to be in this range. If we have just this here, then this can be any character which goes beyond A. And here it's actually giving the boundary. So we say it has to be larger than A and smaller than Z. And what we actually do here is we comparing the ASCII code. I hope that you have still in mind what the ASCII code is about. And what we do here is actually we compare if the ASCII value for B is between A and Z. This is actually what we're doing here. And we combine this with the logical AND operator. Be careful, there is a difference between one AND and two AND symbols. This is in many different programming languages always a bit different. Sometimes it's a keyword which is AND. Sometimes it's just one sign. Sometimes in C, for example, it's two. And there is a difference between both of them. So keep that in mind because there's another operator for just one AND sign. Another idea that I had is to use logical operators for decisions where we usually have it. We talked about if and else already, and what we are doing here is actually we have an operation and check if the number is not equal to 0. So this sign might be new for some of you. Does someone knows what this is actually? Yeah, a mod. Exactly. It's a modulo operator. What does the modulo operator does actually? So what is the idea of modulo? Yeah, it's the remainder, the rest. So if we divide something, if we divide 4 by 2, we don't get a rest, a remainder. And if we do this with 5, then we get 1. And this is actually what the program does. If it's equal to 0, then it's an even number. If it's not equals, then it's an odd number. Gerade und ungerade Zahl, actually. So this is what this very easy program does. Checks if there is a remainder, and if it's 1, it's odd, otherwise it's even. That's the idea of that. Okay, now it might get a bit confusing with the bitwise operators. I promise you this will not be the focus of this course. You will do this in other courses. We want that you have an idea that these things exist, what they are doing, but please don't let yourself confuse too much with that. And actually, I think we have a coding session dedicated, which is at the very end of the semester, where we will talk about that. So you will hear about that today. You shouldn't forget it immediately, but you won't need it the entire semester. So actually, what we're having here are bitwise operators. So all operations take place on bits and not on the entire expression. So what I mean by that is the following thing. These two lines are basically quite easy. It's just a summand. And what we have here is a bitwise AND operator. And now we have A and B on a bitwise level, so we're comparing bit by bit. Okay, what does this mean? We'll start with the very last, I start with the very last bits, is a 0 and a 0. And if we have a bitwise end, both should be 1, that we have a 1 here. So false and false is false actually. Here, false and true is also false. True and false is also false. But now, true and true is true. And obviously, false and false is also false. So what we do is we don't compare it on a large scale, like on entire expression. We compare it on a bit layer. This is also the same with an OR operator. So what we're doing here is actually we're saying A or B, bitwise OR. And so one has to be true at least so that it gets true. So what we're doing here is actually we're saying, okay, 0 and 0, 0 or 0 is actually false. 0 and 1, which is false and true, is true. True and false is true. True and true is true. And again, with 0, we don't care about them.
So basically,
Okay,
one of them has to be true in this case.
One of them has to be true.
To be true, yeah.
Okay, we have this operator as well. This is a exclusive OR, which means exklusives oder. I think in German it's easier to explain. It's a entweder oder. So one of both has to be true or false, but not both. So it's basically the same like the bitwise OR, but with one difference. As you can see here, I say one has to be true, one has to be false. And here it's both, which are true, which here would be true, and here it's false. This is the only difference, X or right, the XOR operator. What we have here is also quite nice. Have a look at the first of this line of the initialization of A. What would you think what this line might do? Probably, yeah, negation. What we're doing here is say, okay, 0 get a 1 and 1 get a 0. So actually we flip it, that 1 is 0 and 0 is 1. And here, this is something that's called bit shifting. And what we're doing here is to say we shift A on with 1 bit on the left side. So what we actually do is to say, okay, we have A, which is this here, and we say, okay, on the left side we will add 1, or on the right side we will add 1 bit. And what we're doing here is say, okay, we have here 0 0 0 0 1 1 0 0, and now we shift it at 1 place, and so it gets 0 0 0 1 1 0 0 0. So this is something that works in both directions. It can be left and the right shift actually.
So in this case, A is 12 in the beginning, and then it's 24. So it's like times 2 operator, so to say.
Right, right. Okay. You could ask yourself now, why do I need this bitwise operators? And actually, when I was in the first semester, I asked this question myself. But you will see throughout your entire study that you need these things a couple of times. For example, in security, for bit masks, also for microcontrollers. Some of you mentioned already some logical getters that you probably need. It's also used in network technology, for example, with IP addresses, and in many different fields as well. As I said, it's not the huge focus of our course here, but this is something that works in many programming languages, and at least you've heard about them, and you know that there are bitwise operators, and you might need them at some point. Okay, so I think 2 or 3 more operators, and then we're done with all the operators that I want to show you. The size of operator is something that is quite helpful in the C programming language, actually. What it does, it gives me the size of a variable, actually. For example, if I write size of A, it prints 1 byte because a character in C here in this implementation is 1 byte. And here, for example, it says 4 bytes because an integer is 4 bytes actually here. This can vary between different implementations, like different architectures of a system. You will see that later. It depends if you have a 32 or a 64 byte system, depending on the implementation actually.
Maybe
And
Alex, just for clarification. So if you print this, it won't print 1 byte. So the byte string is not there. It
yeah,
prints only the
one.
integers of the value 1 or 4.
Thanks for the clarification. So it is really just 1 and 4
Yeah,
actually, right? Can sizeof be used on arrays? Yes and no. It's a bit tricky.
that's very
Um,
tricky.
it's very tricky actually. Um, it's sometimes quite good to actually see the size of an array because you want to go through the array and iterate over it. I promise you that we will talk about that later because there are some tricks in the C programming language on how to do this.
Yeah,
All right.
a good question.
Yeah, that's a really good question, and you will need that later on, definitely. There is also a comma operator, which is used to link expressions together. Cool thing, but also be careful when doing that. Because here you say, okay, you're having in one line 4 characters. For example, here A as the value 4 and C and D are not initialized. So you don't put a value on C and D. That works just by the comma operator, but maybe you also want to initialize these variables as well.
Maybe a question in the chat, what does not initialized mean? So is there nothing inside, or is it then zeroed, or what does this mean if we do not write a value inside a
The
variable?
thing is that in C, it means I don't have any idea what's happening here. In other programming languages, it's, for example, initialized with 0 or whatever. In C, it's just any value. So it can be anything. It's not specified, actually. And this is the thing why we should initialize variables at the very beginning, at least before we work with them. Because if you have now some check, if Z has a certain value, then yeah, it can be some undefined behavior that we don't want to have.
Question was why it can be any value, and the answer is that so you get a specific storage in the memory for this variable, and you do not know what's inside this memory location. So it might be that there is 24 or 42 or whatever value inside. So you do not know what value is currently at this location where which is assigned now to this variable. That's why
Right.
it can be anything.
Okay. uh, let's continue with the address of operator. This is an operator which is really helpful for us, especially in, I think the next lecture, actually, David, correct me if I'm wrong, next or in two
I think
weeks
it's the
from
next
now.
one, which
Yeah.
is getting even more interesting then, yeah?
Yeah, then we will talk much more about addresses, like let's phrase it like that. What we can do with the address of operator is the following thing. Address or a variable has a value and an address in the memory. And with this operator, we get the address in the memory. So we know actually on what spot of the memory this variable actually is. This is what the address of operator actually is. And you will understand why we need this, especially in the next week, because then we will talk about a concept called pointers, which is actually a cool idea, an idea what that happens a lot in C, where we point to different memory locations. But as I said, we'll talk about this much more next week, and then you will understand why we'll need that. Okay, last thing to operators. Operators have different priorities, and this is a table that I created for you to actually see the priority or precedence. Priority means that certain operators are prioritized over other operators. So, for example, the increment, postfix increment or prefix increment is much stronger than the addition and subtraction. And so we actually, sorry. And so we actually also have an idea why things like the assignment and the plus worked in some examples earlier, because when we say x equals 5 plus 4, the plus is evaluated first, addition, and then you will have the assignment. So first the addition takes place and then it gets assigned. And so this is actually the idea of this priority list.
So the
Be
later in
sometimes
this
quite
list,
helpful.
so the later it is mentioned in this list, the less is its priority, right?
Right.
So this is really a table where I think I've never really studied it, but sometimes I looked into it in the beginning. But after, let's say, a few weeks or months, you have a feeling what is a higher priority. So you do not have to really learn this this whole table, but you get a feeling. And if you're unsure what has more priority, just use parentheses, so Klammern in German.
Mm-hmm.
Um, and then you can, yeah, of course we know it from math. You can trick it a little bit and say, okay, I want to do first this calculation and then the next calculation.
Right. So, as David said, this will not be something that we will cover in the exam that you have to know by heart. You will get a sense about that, and sometimes you will have to have the understanding what's evaluated first, which operator is more important in terms of the priority, but you will get to that point. Okay, I
Great.
think I talked
So
now much
yeah,
about operators.
so many operators. I think we covered nearly all. So that was the grammar of the programming language, so to say.
Yep.
I hope you're still alive. Chat is very silent now. I hope we're still online. But yeah, let's continue maybe with a little bit, yeah, or with another topic. Let's call it like this. Um, Maybe go to the next slide, Alex, because I think you know that. Yeah, this one. Perfect. We talked about it a few weeks ago. This was our very basic instructions and memory and our CPU, where we showed how a small instruction or a small program is executed in the CPU. And as you might remember, on the right side, you see the main memory where the program code is inside and also the variables are inside. So now let's look a little bit closer into this memory. We can also visualize it like this. So this memory is just machine code, yeah, but it's of course for us very hard to read. And I think no one of us can really write this machine code to execute programs. So what we normally have is C code. This is a little bit more familiar, but how do we get from this C code to this machine code, which the computer understands? And the keyword I think all of you know in this case is a compiler. So a compiler does all the magic in the background, which converts this C code into a machine readable code, into a code which a computer can understand, then operate. And this is also the code we have seen before a few weeks ago, which then the CPU uh, executes, operates on these instructions, and the variables are stored into this machine code. But luckily, we do not have to deal with this machine code. We can write C code and use the compiler to convert our code to this machine code. And the compiler has a few components. So compiler is mostly the general over term for this. So we have our source code like shown here. And in the first step, we have a pre-processing step. We will refer to this pre-processing step in the future sometimes because I think it's a little bit harder to understand what happens in this step. And when we come to this concept where it, it calculates or it operates in this pre-processing, we will refer to it. But just keep in mind, pre-processing is a store or is one component of the compiler or of the compiling process. After pre-processing, we have still the source code, and then comes the compiler, which changed our source code to an assembly code. Assembly code looks something like this. It's less readable, but it's still readable, and it is most likely much longer than source code. So there are people, and also you will learn a little bit about assembly code, and there are people who can read and write assembly code, but it's harder and you're less efficient. So that's why we want to write source code and not assembly code. But we have this intermediate step from the compiler where where the compiler creates this assembly code. And then on the next step from the assembly code, linker, and I've forgot or not forgot, I've on purpose let's hear something out, but the linker and another thing, uh, yeah, used this assembly code and then also includes other files like headers you have implemented and converted it to a machine readable code. So this assembly code is an intermediate step. Then there is a linker. You get an object file, and this is pretty much machine code. And then it will be converted to this machine code we have seen before. And this then is the machine code the CPU can read.
Thanks for this explanation, David. Some points from the chat and also some notes from my side. Actually, we worked already with assembly in one of the first lectures. Actually, David did that. Actually, if you can remember, David had this super simple computer where we had just like one or two operations, and these operations are actually were like some kind of assembly code. And this is the same what actually assembly does. This is like a intermediate code between like the source code and the machine code. You won't write assembly code here in this course, but for all of you that want to do this, actually, I think you will do this even the next or the semester after that. So there will be a time in the CS degree where you will definitely do that, which is not here. So this is more of a information what it actually is and yeah, what the compiler does, so that you get a sense of that. There are different compilers, and you know already one, Clang. There's also GCC, for example. So there are different compilers, and they're doing something slightly different. So they all have to yeah, basically follow the C standard. Otherwise, it's not really fun because then someone implements that, someone like that, depending on the compiler. But what is different is sometimes the entire software package that is delivered. So sometimes you have cool bunch of tools that are delivered with the compiler. Sometimes they have some optimizations that others won't have. So yeah, there are different compilers. Actually, Clang and GCC are the most famous compilers that you use in C. Yeah. There was also this question, what is an interpreter? What is a compiler? I think that this is covered already in the chat. Benji3D covered that. I don't have anything to add at that point to that. So I think this is good for now. Yeah. Which assembly language, David, what did you choose there?
Um, I don't know. I think I used GCC compiler for that, but I don't know the exact specification. To be honest, I just copied inside which, and it is I think not the whole program you see on the left. It's just a small part of it because it's getting huge. So small programs do really get huge. Bigger programs, of course, even bigger, but this is just a small piece of it, and I don't know exactly which. Wow, what's the specification of that?
Cool thing is you can generate it actually. So when you compile it with Clang or GCC, you can generate this intermediate assembly code when using a certain option. Then you can also have a look at that, which is quite nice to get an idea. But actually, at this point, it's maybe a bit too much. So, but it's possible.
Yeah, and we also have to continue because we have much more slides to come up. And
Yeah.
yeah, the compiler, I think most of you is most of this is already covered or was already covered in the practicals. So we will go quickly over that. Clang is the compiler, then you can add the Z file to it. This converts the source code to machine code. Then we can add warnings. So this W all, so warnings all. Also, I think Michi mentioned it today, where you can optional, yeah, enable warnings. And then you can also specify with this -O option to create a program or to create the output. So -O stands for output. The output should be called, in this case, my program. And you can call it then by, okay, that comes on the next slide. You can watch this machine readable using, for example, the XXD -B option. So this is just another feature of inside the bash. You can see then this is for our machine readable code, for example, if you're interested. And this is also really that machine readable code that is then displayed in the memory. So exactly, this is the memory as we have seen before. Then this is the machine readable code we produced with Clang. So now it comes to execution. Execution, as you have maybe seen from the practicals, with this dot slash and then the program name, you can execute the program and then it's executed until it's finished.
That's actually it. So this is the pipeline for how to um, get actually a executable program in binary out of like a C file.
Yeah. So as you might have seen that my program before used something where it waits for user input. And when I execute this program also, you have to enter a number, then it waits for user input, and then it just prints the input you gave it. So how does this user input work? Then we come to a very interesting and very important topic on my perspective, because you also would need it for the assignment. So how does this user input in general work? The first thing or the first function you could use is, I think you know printf, and printf prints a formatted text. And then there is scanf, which just reads a formatted text. So you can use this scanf, then again with this percentage and d, and a little bit a difference to this printf is that you need this address operator. Anybody knows or can remember why this address operator is needed here?
So the question is, what is this operator actually in the scanf?
Yeah,
What is it, and why on earth would David place it exactly here? Yeah,
location.
Muhammad is on a
Yeah,
good way. This refers to pointer memory location. It's a pointer.
memory
Yeah,
location is quite good. Yeah,
it has to do with pointers, especially we will talk about that next week. What it actually does is something really cool. It says write the user input in the memory to this certain location. Actually, it gives an address. It's as you, I don't know, if you get a letter or a package or whatever, then you need an address where you actually get it, where you receive it. And this is the same thing that happens here with this operator. We say, okay, take some user input and store it at this memory location.
exactly. Yeah, so to get the address we want to store. Another function which you can use is getchar. Getchar is like scanf, but you do not need this formatted text inside. Getchar just reads one character you enter. So as soon as you come into your code to this line of code where getchar is called, it waits until you press one key on your keyboard, and it stores then the value who is entered in this input variable. And another user input function is fgets, for example, a little bit more complicated, but also has a little bit more functionality. So getchar only reads one character, and with fgets, you can read a line of text. And in this case, you can specify how much do you want to read. So we created a buffer of characters with 100 characters. And then we want to write it into the buffer with this fgets. And fgets also needs the size, how many characters do you want to read? And the size of operator is already introduced by Alex before. So the size of this buffer, which is 100 in this case. And the last argument is this stdin, which stands for standard input. And this means basically the keyboard. And then, of course, with printf, you can print it, and you can use here this percentage s format string, which means that's a string you want to display. Right. Were there any questions in the chat, Alex? Or
Not really. Many were already answered, and if there are some questions left,
perfect,
myself or someone else would love to answer them. So please put it in the chat, and
perfect.
then you can continue that.
Okay. Yeah, I think so. Also conditions is already mentioned in yeah, from us previous lecture and also from Michi and Julia in the practicals, so we can go a little bit faster over it. Of course, we know there can be an if. You can use the scanf function and read something from the user, and then, okay, depending on the user input, you can use if or else, or if else. So there are different varieties. The basic version is this, where you can say, okay, if the number is smaller than 3, print something. The next version then, Alex, yeah, is then you can add an else to it, or an even more advanced option would be you can use this else if function, and you can use it as often as you like. So you can really write if, else if, else if, else if, else if, and then an else in the end. So this is the way it should be structured. And on the right, you can see the different operators, as we all have seen before. The values, so 0 means false, and all other real values means true in this case.
Maybe
So now
I
I have,
can just
yep,
one short thing. Boris asked the question in
sure.
the chat. Still do not get this address of operator. So actually, you usually have to use this AND operator, the address of operator, because it gives you the address of the memory, like the address of this variable in the memory. So you use this with numbers and character and floating numbers, whatever, but you don't need it with strings. And this is what maybe caused some confusion, because a string internally in C is an array of characters. This means, as David showed you, if you have the string hello, for example, you have on the address 0 the H, then at 1 you have the A, L, L, O, and then this backslash 0 thingy. Um, the string actually is not the entire text, it's actually the location in the memory. So a string variable is actually just the very first address of this array. I hope this makes sense. So you don't have in a variable like the entire addresses, you have the first one. And this is the cool thing with strings, because you know, okay, this is the starting point, and you always know the last element, because the last element in a string is always backslash 0. And so since you have a string, and the string is already actually the address, you don't need this, because scanf needs an address. And if you just place number here, it's not an address, it's the value of number actually. And this is the reason why you need the address of operator with non-strings, let's phrase it like that, with non-addresses.
Yeah,
Boris, I hope this is clearer.
yeah, we will talk about this, especially the whole next lecture, I think. So
Yeah,
if it is not completely, or if you are not completely understood it until now, it's fine, because the whole next lecture will be about this addresses and pointers and so on. So this um, that's fine.
yeah. We also prepared some nice visualizations for that. Um, this makes it usually clearer, especially when talking about memory.
Sure,
Okay,
yeah.
David, sorry.
Don't worry. So I have a quiz now for the chat. What's the output of this? So Alex, I know you are much older than me. So this is of course our true age. So I'm 21, you are 23. And yeah, what's the output of this? Maybe we can ask that in the chat. What do you think? What's the output of this code snippet? So it's a combination now of conditions, what we have seen, what operators, um, different types of operators. You look younger, yeah. Thank you. That's uh, that's the correct answer. Many just say A. Age is smaller than 20. Is that true? No, that's not true, because it's 21. And Alex's age is smaller than 22. That's also not true because it's 23. So both first conditions are false. So the first if cannot be true. Then David age is smaller or equal to 21. That's true because it is 21. And Alex's age is unequal to 23. For 23, that's false because it is 23. So that's also not true. And then the output or the result is C. That's the correct output. Okay. Um, we also have seen now, or as I said, that you can write as many else if statements as you wish. And sometimes you just have something like this, and this is just a short version of it. I have not much space for all of the days, but you can see Monday, Tuesday, Wednesday. So depending on maybe a user input, if the day is 1, then printf Monday. If the day is 2, printf Tuesday, and so on. So I've already shortened it, but there is an even shorter version of it, which is called switch case. And at a switch case, you can say, okay, switch and then the variable. And in case 1, print Monday. If it's 2, print Tuesday. If it's 3, print Thursday, and so on. You always should write this default in the end because this means that if none of the cases above is applicable, then you can, or this default value. So it's like an else statement in the end. Um, somebody knows what's the output of this on the right side here. Any guesses? Alex, you are laughing a little bit, so I think you saw something. Do you?
Yeah, now I laughed about the comment
Okay.
Friday, Saturday, Sunday. Oh no.
Yeah, I have to shorten it. It was not possible to read otherwise. So yeah, some of you have already spotted the thing with switch cases because the output here is maybe you show the output, Alex. It's Wednesday. Oh no, and that's a problem. And the reason for that is so-called fall through. So the first case, which is true, in this case, the case 3, will be printed or will be executed. And then all the other cases, even the default case, will also be executed. And to yeah to find a way that it's not that, you have to insert a break statement inside after all these cases. So at the end of case 1, case 2, case 3, and so on, write this break statement, and this means that it ends the switch case and continues after the switch case. Of course, you could also write it after the default or in the default at the end, but it's already at the end, so it has no effect. Okay, is this clear? What were there any questions, Alex?
Just one question. Why should we use switch case if it jumps like go-to? It doesn't jump like go-to. Go-to does
Oh,
something different. Go-to says you go to a certain location. What switch case actually does is it proceeds as it should. And if you have a break, then it does exactly what you want to do. It's also the same with if. You can also have multiple ifs, and then you also would jump around within the ifs. So it's no jumping as go-to would jump. The thing is, you just have to add break, and then you're good.
yeah.
Or not. I mean, it depends what you want to do actually, because there is an idea of this breaks, but usually you shouldn't forget the breaks because you don't want to
It's
get
one
to
of
the
the most
default.
common errors when using
Yep.
switch cases. Yeah. Okay, so is there an even shorter way to write this if-else statements? And of course it is, because programmers are lazy. And it is something like this. So you can also write this ternary operator where you first have the condition, then you have this question mark, and then you have the expression if the condition is true, and the double point, and then if the condition is false. So maybe go to the next one. Exactly, here's also the explanation for it. So a condition, then the question mark, then the expression if it's true, and then the expression if it's false. You can really use it for simple operations because it make code shorter, but of course it's not that easy to read. And please do not use it for complex or even nested conditions. So you have this operator. So in this expression, if true, you could write again this condition and again these operators, but it's very hard to read. So for simple things, you can use it. But yeah, for complex or nested conditions, please use the if else on the left side. Great. So that was it from conditions. Now let's move to arrays. And I think most of you, or hopefully can remember arrays from the last time. We defined this integer array. Yeah, thank you. We have just a few numbers inside and how are they initialized in C. So we can initialize it using writing int numbers and then the size of the array. And then for each of the indexes, we can write a number inside. Or we can use something called initializer. And initializer, as you can see, you can write it directly as a declaration, like a variable where you can store values inside. You can, yeah, store the values in one line. And there are so many ways to initialize arrays. I have linked you something here. We will upload the slides afterwards. So have a look at it. There are so many ways you can initialize and pretty interesting ways. And if you want to access an array, of course, as you might have seen, just access it. So, okay, now I've got it. Using, in this case, number and on the index 0 is equal to 42, for example. And yeah, so you can access all this. So remember, or imagine we want to print all the numbers. Okay, of course, we can access the numbers at the index 0, at the index 1, index 2, index 3, and just print it. But what if we have more than 4 values? What if we have thousands of values? I don't know. This is very, very hard. And for that, the easiest solution is, of course, to use loops. So, for example, we have for loop, which counts or start at the index 0. So it basically is the same as above, but it starts at the index 0. So the counter variable is 0. It counts until it's less than 4. And the counter variable is incremented. Here we can see this increment from Alex before. And then we just have one print statement. And the cool thing is, depending on the size of the array, we can now make it much easier. So let's say we have here 1,000 values in this array. We just need to change one thing in the code, which is the counter less than 4, let's say less than 1,000 then, and it will do the same. And we also could use, of course, a while loop. A while loop is, or others, so to say, another way around. A for loop is just another way to write a while loop. They're basically the same. And you can write as seen here. This is really the complete same code. You have a counter variable, you increment the counter at the end of the while, and you print your numbers. So we are already directly into loops, and I want to show you the difference between the types of loops. So we have learned that while loop and the for loop are basically the same. But there is another thing, the do while loop. So the while loop starts, then it checks against the condition. And if the condition is true, it does the task and checks the condition again until the condition is false. And then it does the next task, which is then under this while loop. And the do while works differently. So it starts, it first does the task, then it checks against the condition. If the condition is true, it does the task again until the condition is false, and then it goes out of this loop and continue with the next task. So this is a big difference, and I will show you this in on the next slide. So in the while loop, the condition is tested before the statement is executed. So it's again the same as before on the left. So you have the condition inside the while, then you have the statement start section where the number is printed and the count is incremented. And in the do while loop, first you have the numbers are printed, the count is incremented, and then the condition is checked if the counter is less than 4. So the output in this case is the same, but not always. And on the next slide, I will give you a short, or are there any questions, Alex, in the meantime to that?
Not really. If a for loop is just the same like a while loop, why does it exist then? There must be. Okay, what David meant by that, actually, there is a difference, of course. And the difference is when you use it. So what David means is that for loops and while loops first check a condition and then they get into the task or like the execution, and the do while starts with first the statement or with the task
Yeah,
and then go to the condition. For loops are usually used if you iterate through something. This is actually when you use for loops, and while
yeah,
loops are usually used if you have a condition that is checked a certain amount of time or should be repeatedly checked.
exactly. But you can write every for loop as while loop, but it will get a little bit longer. So a for loop is a special case of a while, which makes something a little bit easier maybe. So especially for accessing arrays or something like that. Okay, so what's the output of this here? Any guesses in the chat? So x is equal to 5, while x is less than 5, printf. Interesting answers. Alex,
Mm-hmm.
what's your thought on that?
Since x equals 5 and I check if 5 is less than 5, I would say we don't get into the loop actually.
Exactly. There's no output on that. So the output is nothing. But at the do while, is there a difference?
I would say yes, since it starts first with, yeah, but let's
Yeah,
see.
that's the difference. Exactly. So you have x is equal to 5, then you print something, and then it is checked if it's true. So that's the main difference. In the first run of the loop, there is the difference if um, the condition is first checked or checked after the statement. That's basically the difference of do while and while loops. Okay. Okay, so I think we're a little bit in a hurry, but yeah, we can manage it. We can do it. So imagine these numbers we have had here are tasks. This should be tasks, not tasks. Are tasks points of one student. So we get 42 points, 0 points, 11 points, and 72 points, and we can print it using this for loop. But what if we have many students? How could we represent this?
So just to be clear, the points there are for assignments, for example, and there are
Yeah,
this student has 42, 0, 11, and 72 points. And the
exactly. So
question now is how can we add different students as well?
exactly.
Okay.
Yeah. So already saw it in the chat. So it's so-called two-dimensional array. So we do not have one line where for the different tasks, but we have for each student a line. So let's suppose we have three students, student A, B, and C, and each of them having points for each of the tasks. And you can show it by, again, having this initialization list or initializing, and you write for both dimensions. So first you have three students, and then you have four tasks, and both of these styles, or maybe the second one is a little bit easier to read, but as you can see, it's completely the same as shown above in the table. So this is how you can initialize an array of two dimensions. And when we want to iterate all over it, one for loop may iterate over one student and all tasks of student A. But if we want to iterate over all students and over all tasks, we need then two for loops. The first for loop goes over all students. So the student counter is from 0 to 3, so 0, 1, and 2. And inside the student counter, so meaning for each student, we want to present the points for each task. And that's why inside the for loop is another for loop where the task counter starts from 0, 1, 2, 3. So going through all the tasks. And then you can print it and exit it like this. And the output is mentioned below. So again, you can see that all the things are printed then. So when we access or when we want to access something, maybe another question in the chat. We want to access now the points of student B at task D. And it's highlighted there. So what do we have to write there that we can access points of student B at task D? Any guesses? That looks good already, yeah. So what is it, Alex? Exactly. It is error, in this case, of the array at the index 1 for the student and at the index 3 for the task. So array at the place 1, 3, and then you can get the output of it. Perfect. So that was our short introduction into arrays. And I think, Alex, you have something left from functions, right?
Yeah, I will just go over some, no 4 minutes, but just to get a sense of functions, and then you will see we talked about many of those things already. So I think this is not something new. This is the example from last week, actually. We have a function, and the function consists of a return type, which is an integer. We have a function name. We have two parameters in that case, two arguments, and a return, which is actually what the system or what the function will return, and it should match with the return type. And then we have a function body. This is actually the anatomy of a function. So now we want to call the function, and calling a function means at the different or at the other spot in the program we want to actually execute the function. Here, for example, we have our main function, and within this main function, we're calling this increase points function. And it's called a function call. And so I jump from the main function into this increase points function now at that point. And here you can see this function. So actually, when I reach this line, points, this value of points, 100, is passed to this original points, and 5 is passed to additional points, and then I can use this here and say, okay, 100 equals 100 plus 5, so 105, and I return 105 here. Yeah, how does the main function knows about this increase points function? And the cool thing is we just put it before the main function. So if we just put it before the main function, then main knows that there is actually this function. Otherwise, the main would say, yeah, okay, nice, but where is this increase points now? And so I just put it in the code before the main function. And another way would be a so-called forward declaration, which is also pretty nice. So we tell the compiler, okay, look, there is a function. The function looks like this, and I promise I will give you the implementation of the function a bit later. How does this look like? Actually, it's like that. You have the main function, and before the main function, you just say, okay, what are the most important parts of a function? It's a return type, it's the name, it's the argument list. And the implementation doesn't matter at this point. So what we say actually here is, okay, there is this function, declare it, and after the main function, we actually implement the function. And this is the so-called forward declaration or function declaration.
Or prototype, yeah. It
Or
also
prototype, yeah. It's
yeah.
also called prototype, yeah. There are different ways for that. And now a question in the chat, are these variables the same? I mean, they're called the same. Are these the same actually?
In the meantime, there was a question, Alex, in the chat. Can you define a function within a function?
I don't think so, actually.
No, it's not. Also Yuki, no, not positive. In C.
In C, yeah, I mean, for example, JavaScript, this is quite common that you do things like that. No. Why not? No, because they are in a different block. Yeah, that's true.
Interesting. Yeah.
And there we have some words that we should know. So there's scope, and the scope is more or less the region where a variable is available with a lifetime, and the variable has a certain lifetime. So we can just access the variable in the program for a certain time. And visibility, which means, yeah, here, for example, points is just visible for this function, but not for this function because we don't pass the function actually, the variable actually.
So the scope is really inside this curled parentheses,
yeah.
right?
Right. So the scope is defined by this parenthesis, which means I have a local scope here for the variable points. Points is just available here. It's just available in the main function. And when I pass it to the function, actually, I don't pass the variable, I just pass the value. I just say, okay, this is 100. And as you can see here, for example, with if, for example, here, if the health decreases under 100, then I decrease a life of the player. And life, for example, is just available in this block. So it's not accessible from any other point. It's just in this block. If I would call it anyhow, I would get some issues, some problems with the compiler actually. And the compiler, you can try it. The compiler actually says, okay, error lives undeclared. Each undeclared identifier is reported only once for each function it appears in. And so it says, okay, you're accessing a variable that I don't know, and I don't know it because it's not in this block. What I could do is access health, and I could also access health here, for example, but lives is not possible to access
So
out
in
of this
inner
scope.
scopes, in inner scopes, so let's say you have this health, and inside the health is available. So if you go, let's say inside a scope, all the other upper scopes are available, but not the other way around. So you cannot access inside a scope, for example.
Right. And last thing, I promise, is something that was already in the chat. There are
Yeah.
so-called global scopes, which means a function would be accessible from any spot within the program. So it's global. This works if I define it outside of functions. And so I define this variable lives, which is available outside. And so I can use it in all of the functions. Actually, I can use it here as I do here, increase lives, decrease lives. I can also use it here. But be very careful with that one, because if they are global, I can manipulate them at any point. So I can, from any spot within the program, manipulate them. And this is the reason why we don't use global variables in ESP. I wouldn't say in general global variables are always bad. There might be some points where you can use them, but in ESP we will learn structured